let's take, what did I say? N equals 1 to infinity, n over n squared plus 3. Is this a p-series? No. Do we all agree that that's not a p-series? Okay. Because of the plus 3 in the bottom, right? Well, all we really covered in this section was p-series and integral test, right? So let's go ahead and do the integral test here. So how do I start when I do an integral test? Change it to a function, okay? Change it to a function. What do I have to worry about for this function?
Figure out if the function's positive and change it to decreasing.
Okay, is this function going to be positive? Right? I'm looking at the interval from 1 to infinity. The numerator's positive, the denominator's positive. So this function is positive on this interval. What about continuous? Yeah, what would make it not continuous? If the denominator was 0. Is the denominator ever 0 on that interval? No. So it's positive and continuous. So why do you say it's decreasing?
Because the bottom's going to be getting bigger faster than the top.
So in order to do that, we've got to establish that the derivative is negative, right? So to do decreasing, you're pretty much going to have to take a derivative here. Because the numerator and denominator are both changing, so you need to make sure that this is always negative. Okay? So what's the derivative of this going to be? Low d high times x over this thing squared, right? So let's simplify that. What's the numerator simplify down to? Negative 2x squared, and then I have an x squared, right? So it'll be 3 minus x squared. So let's first look at the denominator. Is the denominator positive or negative? It's positive because it's something squared, right? So the denominator is never negative. What about the numerator? I want to know when is that negative. So I'm going to see when is 3 minus x squared less than 0. So I'm only looking for x being positive values. So I know that this is negative when x is bigger than the square root of 3. So this tells me I'm decreasing on this interval square root of 3 to infinity. It's okay that it's not 1. We just need it to be decreasing forever on after a certain point, okay? So this establishes that I'm decreasing on this interval here, okay? All right, so we've established positive, continuous, decreasing. What do we do after that? Compute an improper integral. So I'm computing the integral from 1 to infinity, x over x squared plus 3. And you told me to turn that into a limit. Okay. Now you're going to integrate that. What are you going to do to integrate that? Do a u sub. What's my u going to be?
X squared plus 3.
Okay, great. So I'm going to do u equals x squared plus 3 du is 2x dx. So I'm getting the limit as t goes to infinity, 1 over u, and I'll have a 1/2 out front. What are my bounds going to be?
6 and
Hold on. How do you get your new bounds?
plug in.
I mean, the U.
Plug into your u. So my bottom number was 1. So it's 4. It's my bottom number.
Oh, I have a question too.
Uh-huh.
Why are we not using square root of 3?
Because we still want to compute from 1 to infinity.
Okay.
We're not using square root of 3. That was just for the decreasing part, which we need to compute the integral.
Oh,
But
square root of 3 is bigger than 1.
so you go back, after you show it's decreasing, remember the bounds for your integral come from
Oh, okay.
the bounds on this guy right here. 1 to infinity, so that's what I have, the same thing for my integral down here, 1 to infinity. Okay, so 4, and then what's my top bound gonna be? T squared plus 3. Great, what's the integral of 1 over u? Natural log. Uh-huh. All right, so let's plug in our two bounds. 1/2 ln t squared plus 3 minus 1/2 ln of 4. What am I going to get for that limit? Infinity, right? The last term is constant, the 1/2 ln 4, but the first term, I go to the inside, t squared plus 3, that goes to infinity, and ln of x, as x goes to infinity, is infinity, so we're getting infinity for here, right? So what does this tell us?
That our series diverges.
Our series diverges, okay? So this tells us that our series, which was n over n squared plus 3, diverges by what test? The integral test. Anytime you say converges or diverges, you should give me a reason, okay? There's my reason right there.